SolidWorks, published by Dassault Systems, is a solid modeling, computer-aided design, and computer-aided engineering computer program. Designers use SolidWorks to solid and surface model products and parts for pitch presentations and manufacturing purposes. Engineers use SolidWorks software to also solid and surface model parts, as well as utilize the digital simulating and testing environments to ensure parts are manufactured correctly and efficiently. SolidWorks utilizes a parametric, feature-based approach to create solid part files and assembly files. Parametric refers to constraints whose values determine the geometry of a 3D modeled part or assembly. Parameters set by the user may refer to line lengths or circle diameters, or geometric parameters such as tangent, parallel, concentric, horizontal, or vertical relations. These parametric values and relationships enable the user to make changes and updates to their 3D models without having to restart the 3D modeling process from scratch. Users begin 3D modeling using 2D sketching techniques to draw shapes, then utilize feature options to extrude those 2D shapes into 3D forms. These 2D sketches consist of geometry such as points, lines, arcs, or splines. Dimensions are added to this geometry to define the size and location of each shape. The parametric nature of SolidWorks means that the dimensions and relations drive the geometry and can be controlled independently at any point during the design process. Parts can be compiled into assembly files to create multi-part products. Assemblies utilize mates to define the conditions and geometry of the 3D modeled parts. Mates are essentially the equivalent to sketch relations in that they allow for the assembly of 3D modeled parts. Once assembled, designs can be analyzed and tested within the digital environment prior to moving to physical prototyping. Drawing files are created from either parts or assemblies. Views are automatically generated for the 3D modeled files. Drawings allow the user to dictate notes and visualize dimensions and tolerances for manufacturing purposes. Industries that regularly utilize SolidWorks include transportation, aerospace, marine, industrial equipment design, tech, consumer products, consumer packaging, medical, energy, architecture and construction, and business services. SolidWorks is used by designers and engineers to prepare their CAD designs for manufacturing processes such as casting, molding, forming, machining, joining, and additive manufacturing. In SolidWorks, you can create a new document or open a pre-existing document. The three main documents to choose from in SolidWorks are Part File, Assembly File, and Drawing File. I've decided to open a pre-existing file. This is a straightforward part file to help explain to you some of the basic attributes of SolidWorks. Before I begin making adjustments to the file, I'm going to save it. First, I'm changing the name of the file, so in the future I'll know which file I have actually edited. There are many file type options to save this part file, but I definitely want to save this as a part. You can see there are options such as STL, DXF, and DWG for exporting for different manufacturing processes. My new file name is displayed up at the top, and if you hover over the name, you can identify exactly where the file is being saved. Over to the left, you'll see the Feature Manager, also known as the design tree. The design tree is like a timeline, and it keeps up with all of the features and sketches you have created so far. Each feature is labeled as a specific part of the pencil 3D model. When you drop down the arrow to the left of the feature, you'll see the sketch that was created prior to the feature. In the top left, you'll see the Command Manager tabs. These tabs are used to create sketches, features, evaluate your 3D model, create simulations of your 3D model, and post-process G-code for CNC operations. When I select the Sketch tab, you can see all of the drawing and editing tools that you can use to create your sketches that will build your 3D models. I'm selecting to edit the sketch under the lead feature so that I can show you how the sketches and features all connect to one another. Before I continue, I'm opening up the View Orientation panel just to make it a little easier to move around this 3D model. I'm selecting the top view so that you can see the circle and the dimension that determine the diameter of the lead feature. Since SolidWorks is a parametric CAD program, at any time during the modeling process, I can go back into the sketches and the features to redimension them. Since I've decided not to redimension this 3D model, I'm going to leave the sketch. The arrow at the top right exits the sketch, but the X discards the sketch, meaning that it'll completely delete it. You can also exit the sketch by selecting Exit Sketch at the top left. Going back to Features, when I select the Features tab in the Command Manager at the top left, you'll see an array of tools that can be used to create and edit features in your 3D model. You can see that I still have the sketch visible underneath the feature. To focus in on only the lead feature, I'm going to move the rollback bar all the way up to the base of the lead features sketch. By doing this, the rollback bar hides all of the features and sketches that are underneath the lead features sketch. Now that I have a more clear view of the lead feature, I've selected to edit that feature just to take a look at the parameters that were originally set. Because the Feature Manager is essentially a timeline, when I go in here to delete the lead feature, everything that was created after that lead feature is deleted. By moving to the top view, you can see that all that remains of this 3D model is the original circle sketch. I've selected to undo the deletion of the original lead feature, and now SolidWorks is telling me that there is an issue with the ferrule revolve feature. Before I move forward with this 3D model, I want to go in here and figure out what's going on with this revolve feature. So I'm dropping down the feature, seeing that there's also an issue with the sketch. So when I go in to edit the sketch, I can see that there are some issues here with the relations. Relations are visible as multicolored squares within your sketch. Green squares mean that everything is good to go, but a yellow or a brownish colored square or red mean that there are some issues that need to be resolved. To get a clearer picture of what's going on here, I've pulled the rollback bar up to right underneath the ferrule revolve sketch, but I'm also selecting to hide the lead feature, the casing feature, and the eraser feature so that I can just focus in on the ferrule revolve. By right-clicking each one of the features in the Feature Manager, I selected the eyeball, which essentially hid each one of those features. Now I'm able to focus in on what's going on with this ferrule revolve. I can see here that I have red and yellow sketch relations popping up, and some of the dimensions are also in yellow. Many times this just means that the sketch is overdefined, underdefined, or there's some type of redundancy within the dimensions. The way to clear this up is to simply select the red or yellow sketch relations and just to delete those. Typically, this will clean up your sketch, and when you exit the sketch, everything will be fine. To retrieve the features that I previously hid, I'm just right-clicking my mouse and selecting Show Hidden Bodies. Within this hidden environment, I can choose to select one feature at a time or just drag my mouse over all of the features to bring them back to the 3D modeling environment. Notice that each one of these features has a corresponding icon to the left of the feature name, and these icons relate directly to the icons in the Command Manager menu in the top left. All of the features that I have selected have a sketch beneath them, so they originated from a 2D sketch. But notice that the fillets, fillet 1 and fillet 2, do not have a corresponding sketch. Fillets are among a group of feature editing tools that do not require sketches, but rather edit pre-existing features. To end this video, I wanted to cover one of my favorite websites to visit for 3D models. GrabCAD is a community where designers, engineers, and hobbyists upload the CAD files and the products that they've created to a community-based network to share their ideas and help other people out with complex models. Be sure to visit the GrabCAD community to get inspiration that will help you create your own innovative ideas.